Let's think about this. What happens if I double my speed? Now this is pretty straightforward, but you want to bear with me even though it's a bit mathematical. In fact, if you just stay with me for a short while, you will see how simple the mathematics is. Now let's think we have any object moving through air, and any object moving through air experiences parasite drag. Right. Parasite drag is form drag plus skin friction drag plus interference drag, etc., etc. Let's just look into form drag. Form drag is ρ12 v square, which is our dynamic pressure, or somehow an expression for our kinetic energy, times c dFO, the coefficient of drag for the form drag specifically, which obviously covers the elements of the form of the object and the frontal area. Now if I take this and I write this in a slightly different manner, then I can write here my form drag equals ρ12 c dFO times A times V square. Not much has changed. Now I'm a bit lazy and I say ρ12 c dFO times A equals a factor K. So instead of saying the names of every single student, I call the class 2B, for instance. Yeah? So K covers all of these elements. And as a consequence, now I can write my form drag equals K times V square. Now I go and I say my form drag 2 has a speed 2 which equals 2 times my original speed, the speed I used up here. So I double my speed. That's the whole story. Now I go back into my original formula, but I have to make it out now for my form drag dFO2, which actually is again ρ12. Now V square is V2 square times c dFO times frontal area. Now I can rewrite this again. D form 2 equals ρ12 c dFO times A times V2 square, and I can use the same definition as above. K is ρ12 c dFO A. Nothing has changed. So my dFO2 becomes K times V2 square. Yeah, very simple. I simply replaced V by V2. And now I do the important step and say my V2 equals 2V. It's twice as much as my original speed. So I go down here and replace V2 by dFO2 equals K. Nothing has changed. Now V2 is 2 times V to the power of 2. Now this is very simple. I go dFO2 equals K times 2V times 2V, correct? I can rewrite this easily. dF2 equals K times V square. These are the two elements, times 4. Now K times V square we have seen before. Look at this. K times V square is dFO. So I can replace K times V square dFO 2 equals K times V square is dFO, my original drag, form drag, times 4, or 4 times dFO. So that means I double my speed, I quadruple my form drag. That is owed to the V square dependency. In the same manner I can say I halve my speed and I make a quarter of my form drag. That applies not only to form drag, but to skin friction drag, to induced drag, and as a matter of fact it also applies to lift, because all these formula have rho half V square as their key element, and that is my dynamic pressure. Rho half V square. That's the way it is.